Next in our notes, we have this example. And it talks about, let's see what exactly it says. It says, in this exercise, assume the object is moving with a constant acceleration in a positive direction of a coordinate line and apply these formulas right here, okay? Now remember, position function, velocity function. S subscript of 0, initial position. V subscript of 0, initial velocity. And A is the acceleration, not initial acceleration, but acceleration, okay? A boat is stopped at a dock. It leaves the dock with a constant acceleration of 4 feet per second squared. At the time the boat leaves the dock, it is 900 feet behind a jet ski traveling with a constant velocity of 30 feet per second. How long will it take the boat to catch the jet ski? How far would the boat be from the dock at that point? All right, so what I'm going to do, I'm going to draw a picture, okay? Here we have a boat. Over here, we have maybe a jet ski, okay? Now, a boat is stopped at a dock and leaves the dock with a constant acceleration of 4 feet per second squared. So I'm going to say A is equal to 4 here, okay? I'm not going to worry about the units right now. At the time the boat leaves the dock, it is 900 feet behind a jet ski. So when it leaves the dock, from here to here is 900 feet, okay? All right, what else did I say? 900 feet behind a jet ski, traveling with a constant velocity of 30 feet per second. So this jet ski has a velocity of 30 feet per second. All right, how long will it take the boat to catch the jet ski? So what's going on with the boat? It's accelerating, right? So eventually, somewhere out here is going to catch the jet ski, right? How far would the boat be from the dock at that point? All right, so what am I looking for? I'm looking for somewhere out here, at some distance here from the dock, is going to catch the jet ski, right? They told us to use this stuff here. Well, let's set up a position function for my boat, okay? So S of t, it talks about, is equal to S naught plus V naught plus, let me write this, S naught plus V naught times t plus 1/2 A times t squared, right? All right, let's see. For my boat then, S of t, my position function is going to be S subscript of 0. Well, what does it talk about? The boat is stopped at a dock and leaves the dock with an acceleration of 4 feet per second squared. So we can look at the dock as position 0 and the jet ski at position 900. So that would make my S subscript of 0, my initial position, 0, plus. If the boat is stopped at the dock, what is the initial velocity? That would also be 0, right? Plus 1/2, and then it ends up accelerating, and the acceleration is 4, right? So if we simplify this function right here, S of t will be what? 2t squared. Now let's look at my position function of my jet ski here. My jet ski is going to have position function the same thing, right? It's going to be S naught plus V naught times t plus 1/2 times A t squared, according to this formula right here. All right, so S of t will be equal to, what is my initial position of my jet ski? Initially, it's what? 900 feet from the dock. So I'm going to put in 900 here. All right, plus V subscript of 0. What is my initial velocity? Initially, right before the boat takes off, or right when the boat takes off, my jet ski is going at a velocity of 30, right? Times that t, plus 1/2 times A times t squared. Well, what is A? If it's going at a constant velocity, the acceleration then is 0. Well, let's clean this up. So S of t is equal to 900 plus 30t, and this stuff zeroes out, right? All right, now, what am I trying to find? I'm trying to find over here where the boat catches the jet ski, right? Well, let me ask you this. What do you know about their positions right here where the boat catches the jet ski? Aren't their positions going to be equal where the boat catches the jet ski? Yeah. So if their positions are going to be equal there, to find where that's at, if their positions are going to be equal, I take this position function from my boat, set it equal to that position function from my jet ski. And I'm going to need more room for this, so I'm going to have to erase here. So what do? Take the position function from my boat, set it equal to the position function from my jet ski. So I have 2t squared is going to equal to 900 plus 30t. All right, that's quadratic, right? Let's get all the terms on one side and 0 on the other. So we have 2t squared minus 30t minus 900 is equal to 0. Well, to solve this, it'll be a little easier if I divide each one of these terms by 2, right? So we have t squared minus 15t minus, what does that give me? 450 is equal to 0. Well, I can either try to factor this or use the quadratic formula. If I try to factor this, let's see what I get. T, let me try maybe 30 here. And what do I put here? Maybe 15? Will that give me 450? Yes, it will. And the 30 is going to be negative, and the 15 is going to be positive, is equal to 0. So now take each one of these factors, here and here, and set them each equal to 0. So t minus 30 is equal to 0. Also, t plus 15 is equal to 0. So t is equal to 30, and t is equal to negative 15, okay? Now, what is t? T is the time it takes for the boat to catch the jet ski. So negative 15 doesn't make sense in the context of this problem, but 30 does. Now let me see if I answered the question, okay? Let's see, it asked me, how long will it take the boat to catch the jet ski? So 30 what? Seconds, right? Then it goes on to ask us, how far would the boat be from the dock at that point? How far would the boat be from the dock? The boat will be blank feet from the dock. Now, how can I find how far the boat will be from the dock at that point? Well, how long do we say it would take for it to get right here? 30 seconds. So couldn't I just plug in 30 seconds into my position function right here? And that'll tell me where the boat's at 30 seconds. Sure can. So S of 30 will be equal to 2 times 30 squared. So what does that give me? 2 times 900, or what? 1,800. So the boat would be 1,800 feet from the dock. All right, let's look at the next example. This one says basically, let's use those same formulas again, okay? Let's use those same formulas again. Let's see, what are those formulas? They say use these formulas again. S of t is equal to S subscript to 0 plus V subscript to 0 times t plus 1/2 at squared. And what is V of t? V of t is equal to V subscript to 0 plus a times t, right? All right, so it says use these same formulas again. And let's see what that means. I'm not going to write all this down. Just look at your notes, okay? It reads, a motorcycle starting from rest speeds up at a constant acceleration of 2.4 meters per second squared. After it has traveled 120 meters, it slows down at a constant acceleration of negative 1.5 meters per second squared until it attains a speed of 18 meters per second. What is the distance traveled by the motorcycle at that point? All right. Let's say we have a motorcycle going like this, okay? Talks about a motorcycle starting from rest speeds up at a constant acceleration of 2.4 meters per second squared. So I'm going to put acceleration at the beginning as 2.4. After it has traveled 120 meters, so I'm going to say, okay, it starts from rest, so it starts at point 0. After it goes 120 meters, what happens? It slows down with a constant acceleration of negative 1.5. So here, slows down with a constant acceleration of negative 1.5 meters per second squared, right? And then it says until it attains a speed of 18 meters per second. So slowing down with that acceleration till it gets somewhere over here. And then what? It has a speed of 18 meters per second. Well, I'm going all in the same direction. I'm going to say instead of putting speed here, let me put velocity here as 18. Okay, we can say it's going in this direction, so therefore it has a velocity of 18 meters per second in that direction, okay? And what does it say here? It says, what is the distance traveled by the motorcycle at that point? So once it gets right here, basically, what is that distance that it traveled? It's greater than 120 meters, right? So we need to find that. All right, what I'm going to do is I'm going to split this into two sections. I'm going to look at the section where the motorcycle went from 0 to 120 meters. Then I'm going to split into the section where the motorcycle went from 120 meters to over here, okay? So let's see. Initially, let's look at a position function of a motorcycle. S of t is equal to S subscript of 0 plus V subscript of 0 times t plus 1/2 AT squared, right? All right, what's my initial position of my motorcycle? 0. What do they talk about the motorcycle? It starts from what? From rest, right? So its initial velocity is 0 as well. Now, what is the acceleration of the motorcycle? 2.4, right? Make sure it did start at rest, right? Yeah. All right, so S of t, if I clean this up, will equal to what? What's 1/2 of 2.4? 1.2 t squared. Now let me come up with my velocity function too, okay? Because I am using velocity in here. So my velocity function v of t, what is that going to be? V subscript of 0 plus a times t. Well, v of t will be equal to, y'all told me the initial velocity was 0, plus a is 2.4 times t, right? Or I could say v of t is equal to 2.4 t like that. All right, so I have my position function and my velocity function for this first part of my trip, right? Let me write my position function and my velocity function for this part of my trip, from here to here, okay? So position function is S of t is equal to S subscript of 0 plus V subscript of 0 t plus 1/2 AT squared, right? So let's see. S of t, what's my initial position right here? Where am I at initially if I start the watch right here? I'm at 120, right? Plus V subscript of 0 times t. What is my initial velocity at this part? I don't know. So I'm going to leave that blank for now. Initial velocity times time. plus 1/2 times a t squared. A is what? Negative 1.5 t squared. All right, I'm going to fill this in a minute, okay? Because I don't know what it is yet. What is my velocity function for this part of my trip right here? What's going to be v subscript of 0 plus at, v subscript of 0 plus at, right? Well, just like before, I don't know what the initial velocity is here, so I'm going to call it blank plus a times t. A is negative 1.5 times t, right? Now, I will have these two functions right here if I have v subscript of 0 or my initial velocity for this part, right? Let me think of how I can find my initial velocity for this part. Okay, so we said before, for the first part, here's my velocity function, right? Here's my position function. Where am I at with this part of my trip? What's my position at to begin with? 120 meters, right? Well, couldn't I take my position function right here and say, let's find out whenever is equal to 120? And then I'll be able to solve for time? Yes, let's do so. So what I'm going to do, so I'm going to take this initial position function, 1.2, or this position function, I'm sorry, not initial position function, 1.2 t squared, and I'm going to find out when is it equal to 120. When is it equal to 120? Yeah, I'm a little bit off the screen here, so let me try to redo this. So position function, 1.2 t squared, where is that equal to 120? All right, I'm on the screen, okay. So that means t squared will equal to what, 100? So t is equal to 10, right? So t is equal to 10. So what do I know? It takes me 10 seconds to get from here to here. It takes a motorcycle 10 seconds to go there, right? So let me see. Couldn't I take the 10 seconds and plug it into my velocity function right here? And that'll give me the velocity when I'm right here. Oh, if I have the velocity when I'm right here, I have the initial velocity then, right? So let's take this original velocity function and let's evaluate it at 10 seconds, okay? What is that? 2.4 times 10, or what? 24, right? So what are we saying the velocity here is 24, or I can look at that as my initial velocity is 24. So that means then that I could put in my initial velocity is 24 here and 24 there, right? So S of t then will equal to 120 plus 24t minus, if I multiply these, 0.75 t squared. And over here, if I clean this up, v of t is equal to 24 minus 1.5 t, right? All right. Now, I found all that stuff, position function, velocity function, position function, velocity function. What do they want me to find? They want me to find what is the distance traveled by the motorcycle at that point. So they want this distance right here, right? How could I find that distance right there? Well, what's the velocity right there? 18. So couldn't I just take this velocity function, find out where it's equal to 18, and that'll give me the time? Well, let's do so. So let's take that velocity function over there, which is this, 24 minus 1.5 t, and find out when that velocity is equal to 18. So we have negative 1.5t is equal to 18 minus 24 gives me what? Negative 6. So then we do what? We divide both sides by negative 1.5, and that's going to give me a positive, right? So that'll give me what? 4? 4 seconds there. All right, so I know the time it took to get here, right? But what do I want? I want to know the distance there. How do I find the distance there? It took 4 seconds to get here. What do? I plug in 4 to my position function, and it'll give me the position there, right? Let's do so. So now let's plug in 4 to my position function here. So S of 4 is going to be what? 120. Oh, I think I'm off the screen again. Hold on. S of 4 is equal to 120 plus 24 times 4 plus 24 times 4 minus 0.75 times what? 4 squared? And if you go ahead and calculate that, what do you get? 204? So 204. And what's my unit for the distance here? Meters.